Sir, please unmute your side.
Okay, sorry, I didn't know that I was mute. Okay, okay, okay. So yesterday we were discussing about the Q point. So once we plot the load line, load line is the point, the intersection between the maximum current and minimum voltage point to the maximum voltage and minimum current point. Okay, you can say V max. Sorry, this is V min, I max. Okay, and this is V max and I min. Okay, this should be reverse. This, first you specify the x-axis, then you specify the y-axis. Okay, so fine. Then over this load line, you plot your device characteristics. Okay, then you'll go to intersection, and that is going to be your Q point. So say V star, operating voltage, and corresponding will get I star. Okay, so and if your device changes, then based on your new device, you find the device characteristics based on the datasheet of the new device, and you plot the device characteristics again over the load line. Now you'll get a new Q point. Okay. So even if you're using the same device, your Q point will be matching based on the device characteristics, temperature variation, etc. There will be slightly changing the Q point. So ideally the designer or the engineer duty is to fix the Q point. Okay, based on the variation in the temperature, humidity, and external circumstances, etc. Okay, so today I'm planning to say, coming to yesterday's topic, I have discussed what are the simple projects or simple applications which you can simulate, or you can have a study on that. Maybe someone can make a fabrication of a small PCB with few components. Okay, like I was remembering last time I given this project to student. They have made some components like a power supply. Okay, power supply meter, not meter, power supply means 5-volt power supply. Charger, like a 5-volt charger, you can make a small LED indicator, something like that. Like someone has made a small thermistor sensor. They're not made, they have bought a thermistor sensor, and based on the temperature, there's a small fan, small motor here connected. The more temperature, the fan is rotating. So what it means, it is not a high end product, but it essentially delivers a concept. Okay, he clears a concept. When there's the sensor has some input, whatever the input, and there is a thermal sensor. There can be water level sensor, there can be moisture sensor, can be light sensor, can be sound sensor, whatever. So based on the input, I'm controlling some output, I'm actuating some output. So there is a whole thing, the concept is that thing. Once you do it, things will be very clear also. Although you think it's very easy, you take a sensor, you take some processing and gives output. It can be voltage or current, or it can be a siren or a loudspeaker. So but when you do it, you can you'll learn much more, because it's not easy as you think. The small things you will be uh, have to you have to be careful of. What is the voltage rating, and what is the device, how it works, okay, etc, etc. So it will be a lot of good learning experience. So some students were asking, what is the level, what level should we go for? I always told that whatever uh, your interest and liking, whatever you're based on your knowledge. Okay, and maybe something you can read a bit read about the something about some circuit, some sensor, simple sensor which is 5 rupee or 10 whatever. So they were asking, is it okay that we can do some, yeah, simulation is also okay, but whatever you can do, you just try something out, something a bit more than your theory what you're learning. So that will help in future. So I explained, some students ask like, said this is okay, yeah, anything is okay, but even simple water controller is okay, not controller, water level indicator. You know how it was, simple water level indicator. So I just want to tell you how it works, how simple it is, and itself is a project. Okay, it's not a project, but it can be considered as a micro or mini project, whatever. Not a mini, but micro. So I'll just explain how the simple. I will explain water level indicator. So you may think that okay, it's a water level indicator. So first we go for the water level indicator. Then we discuss water level controller. Then we discuss water automatic water level controller. Okay, when we're thinking of some application, for example, water level controller, we can make it automatic. We can make it semi-automatic. We can make it manual. Everything is fine. Ultimately, what is manual? You have already switches which fully under the control of a human beings or user have the full control to make it on and off. Okay, and no other electronics doesn't have any intelligence to make it on and off otherwise. But semi-automatic means some part of the uh, work may be done by the user, and other part may be, say for example, semi-automatic means your water level is full, the tank, your tank water level is full, so it gives a siren. So it is semi, you can say there is a indication from the electronic part, and maybe it can give a display also, a red light, whatever. Then you have to turn it off. Ideally, a circuit of a good project gives an automatic controller. That means automatic, we can automatically, when the water level is high, the tank should be automatically, or the motor should be automatically off. Okay, so one thing here, I'll just very brief. This is, assume this is a tank. Now when it is full, what I want the LED to blink. That is a simple water level indicator. So how, very simple circuit you can implement this. You can use a battery. Simple. I'm just using a 9-volt battery, 5-volt battery, whatever, DC. I'm just assuming DC. Okay. Now there may be once you are doing some project, you will learn a lot of other things also. You may learn some physics. You may learn some chemistry. You may learn some practical common sense or practical examples, etc. So what I'm saying, I'm in a plus and minus battery. I add plus here, point and minus point is okay, whatever. So now my output should be, out needs to be a LED. You can see indicating. I can indicate something. Okay, I need to indicate the whether water level is full or not. So my output should be, first you should decide this what a sensor and what kind of output you need. Okay, maybe you can have a loudspeaker also, but fine. This is fine. I think light is getting on. Now you may think, what is my principle? Ultimately, whatever input sensing, you have to use some physical principles. It can be used some chemistry, whatever. This is basic common sense only. Okay, so here usually there's one kind of sensor which we can try also very easily. A small voltage. I don't need this. I don't think I need a 9 volt here. I need very less voltage. Even 5 volt is sufficient. Okay, 5 volt is sufficient. 5 volt battery. Okay. Now what I'm doing is, I'll just connect connect the 5 volt battery, and I fix this a wire here. Okay, I'm fixing a wire here, and I'm adding a small resistance. You know, it here I can put it in the bottom also. Put some resistance here. Okay, and I can connect it to ground. Okay, the minus point anyway I can connect it to ground. Both the same. Fine. Okay, so then what I'll do, another wire again. I will take another wire and connected to the LED fan. Okay, so this is a resistance. So this is a very simple circuit. We can say this works as a water level indicator. Now there are a lot of questions will be here, like what is my idea here? What I'm trying to do here? Can anyone guess what I'm trying to do here? This is a conductor. You can say wire, white color wire. Can you tell me what I'm trying to do here? Yeah, any so I'll just explain what I'm trying to do. Then I'll think a lot of you people have a lot of questions. So I'll explain what I'm trying to do here. So my idea is, there is always, there is a mm, there's a pipe. There is a pipe, and this pipe is what is found by a motor. I'm not interested in circuit of motor or something. So the water is continuously flowing, and when the water level becomes high I am maximum height of the tank is full. So what I assume is, I assume when the water level is full, this is connected to the other terminal. No, I think a lot of you, yes, Ankit is asking, yeah, this is what I expected. Yes, this is something, water conduction through, yeah, this is right. So I think anyone has any question regarding, I think a lot of people may ask, sir, how can water conduct? Yeah, this is a mystery because we have already learned in our basic chemistry or physics, I think, pure water is a insulator, right? Or there was, I don't know. When I was trying to understand this thing, I was remembering that I had learned that pure water is a insulator, it's a bad conductor of electricity. Yeah, any comments on this, anyone? What about you? Have you learned anything? Do you remember something about water? Will water, or in general, I am asking if this works or not. I'm trying to make an indicator in my kitchen, and this portion I'm putting in my kitchen. This portion LED will go from my kitchen. So when water is full, I'll get a small indication in the kitchen. Okay, that is only my idea. So, so what I'll do, so sometimes you will think, okay, kitchen, I may not be watching the LED all the time. So what can I do? I can do one more, sorry. Oh, sorry. Okay. So what I can do, again, no problem. It's very simple circuit. So what I'll do, I can not only have a LED, I can have a loudspeaker also. Loudspeaker also. It have some resistance, so I need not keep still. I'm keeping a resistance for the. Uh, okay. Again, this circuit is remaining same. Okay. So my what is my idea? Again, in the kitchen I can have a loudspeaker. Then whenever water is full, I can have an indication in the loudspeaker. Okay. So my idea is when water level is empty, there's no problem. I don't need to on or alert anything. Don't need to make the motor off. Still, I will let it run. So again, when it becomes the full, I'm assuming that this water level is connecting. Now the circuit is complete. Okay, now this 5 volt order can complete and loudspeaker right now will be on. So then I'm working in the kitchen, I can see that okay, it's time to off my order. This is not an automatic thing, this is actually a manual thing only, because I'm seeing that level. Okay, but I have an indicator, I have water level indicator here. Now, I think a lot of students might have questions. So, how is possible water is conducting? Yes, this is one question. When I was working also, I was thinking how water. But when you test it, when you buy a small LED and you test the same circuit, whatever water, whichever area you're collecting water, even if your home, your water tank, even if your municipality corporation water, village pond, well water, whatever you test is any water, you can see that the water is actually conducting. So whatever water available around us is a good conductor of electricity. You can see it. We may see that okay, there's a shock whenever there's an electric line, electric post in the rainy season when electric post fell into the nearby pond. You can see a lot of animals die, even cows, buffaloes, and they will cattle die. This happens, and not only in the ponds, even in the rainy season when some electric post or something is has been fallen into the ground. If there is a very heavy level of water, you can see that when you touch that water, you will get electric shock. This is only a very extreme example, but you can see you will not get a sample of water which is insulator. But you may get in lab if you make a pure water using distillation, or you distill water we can do using some chemical process. That I can say there's a laboratory level water that is can it will be high purity. Then I can say there is no dissolved salts or impurities within the water. Then you can say okay, that water is an insulator. Maybe it has some very high heavy or very high resistance. But what is practically but as a designer engineer, we are always looking towards practicality. Whatever we learn theory may not be practical many of the times. It is only theoretical only. I also learned that water is an insulator, but this is not practical. Whatever water available around us is very good conductor. Why? Because there is a dissolved salts. Even if you have a distilled perfectly laboratory made water, within few hours or some time it can become conductor because of the atmospheric salts getting dissolved in it and whatever. So the point is, when you start designing something, when you start working on a problem, as an engineer, also as a project leader or as a project team member, you will be learning a lot of physical principles, a lot of common sense things which we don't know before, which can be about the water, it can be about the light, it can be about the frequencies around us, a lot of things. We can. So this is one physical thing which I learned when I was trying to make a water level indicator. Okay, so now what is it getting? Whenever your water level is full, I'm getting a high sound. I can get a LED also. Parallel, I can make LED also. Now I can have different levels. I can also keep lot of conductors here to at different levels of the tank to give me indication. To give me indication that this is this much full. Okay. Now I'm keeping a mid. Whenever this LED is on, I know that water level is the tank is mid full. Okay. Again, again I can have one more conductor, something like this, which shows me this is around empty only. Okay. Okay, this LED output, this LED shows that when this LED, so this is one, I can call this is one first LED, second LED. When one and two are on, I know water level is still around middle. If two is only on, I know this is around empty, water level is around empty. Okay, so that's it. So simple figure. Now how to improve from here? Now I'm just having a manual control. Now what is the advantage of manual control? At least when someone is in the kitchen or someone is in the home, I can know that the water level in the tank is full, so I can go manually put it off. So definitely I'll be saving a lot of what? Lot of water which is to be wasted if I am not putting it off, and a lot of electricity also. And we also protect the overheating of the motor. Sometimes motor is kept on running for a long time. It can get burned because of the heat, heavy heat produced. Okay, it can get burned. So we are saving electricity, we are saving water, we are saving resources, etc. Okay. Now I want to make it a bit more advanced. I'm how to make it automatic. Automatic means without any human interference. My circuit should be capable of sensing whether the water is full in the tank and automatically should make the motor off. So what should I do for that? Okay. So what is the main thing? Our circuit looks like this. There's a motor. There's a motor. Now the motor is always on while the water is coming into the tank. Motor is on, so I'm showing the circuit of motor. So I'm just showing a circuit of motor. You buy a motor from the market, and this is the circuit looks like. Okay, here you can see, here we don't have a DC. Till now we were discussing, your transistor, diode, everything on DC. Now this is AC. Okay, when you try the specification, you can know that it is 230 volt, 230 or 240 volt, 50 hertz, 50 hertz frequency. Okay, this is the rating of the input AC, and this is switch is called, you can switch motor switch S1 or SM. Okay, so this is the household AC circuit diagram of a motor. This is manual control. When you put it on, motor start running, and put it off. So now if you want to make it automatic, you need to have some kind of intelligence here. That is what we are discussed in the early class. We need some kind of sensing mechanism. Here we are discussed sensing using the property of conduction of water, whatever. So this sensor has to control this switch. Ready? Okay. So sensor, we already know what kind of sensing we can use. One very simple idea is what we already discussed. We can have a tank. We can have two conductors. We can have two conductors here, the top position, bottom position, and we can have some supply, positive supply. And when this connect here, I can have a current or voltage here. I or V is in the output. So this acts as a sensing mechanism. Okay. When if and only if there is a water level is full, water level is high, I can give an indication here, 1 or 0, whatever. If 1 means there's signal in the wire, that means the signal coming from the uh, water being high in the tank. Okay, so sensing part is, this is my sensing idea. I'm using a wire which gives a positive voltage or signal or current in me output. And what is the output? I need to control the switch. Okay, so here we know that water level is full. For example, I'm giving a positive supply in the left of the conductor within the tank. So when water level is full, I'll get a high value or voltage. I can assume that is a voltage. I'm getting a V equal to 1. V equal to 1 when my sensor is giving high volt. That means when water level is full, I get, so I can say water level is high or full. That means V output here equal to 1. That means what should do with my output, switch should be off. S1 should be off or 0. Okay, and water level is low. That means water tank is not full. That means voltage I'll get is 0 because there is no conduction here, and your S should be automatically, so it should be on. That should be on. Okay. So what I did based on my problem statement, I have to automatically control my motor. So I need a switch, controlling switch. That is a usual household wiring, AC wiring circuit. I have to make the switch on and off depending upon the water level the tank is full or not. Okay. So I'll make a logical connection like this. Now I'll start designing. So how to design? Now one thing we are discussing here is we are trying to control a AC circuit thing, something which is very high voltage. 230 volt is very high volt, but DC 5 volt is very small voltage. 9 volt batteries can get in 10 rupees. They are less DC voltage, and power level also is very less. We can make a small motor run with it. LED on a loudspeaker, we can make a kick sound. So that are low power devices, low voltage DC voltage. But here we have motors. Household circuit is high power thing. You can 1 HP, 2 HP, 1.5 HP, whatever. Okay, so this motor have working on a high power circuit, 230 volt AC. So this try a lot of current to it. Very dangerous also. So we need to connect a low voltage circuit sensing. First, this is low voltage circuit. There is sensor. I call it S, and this low voltage circuit is processing that sense what the voltage signal. Then I'm controlling a high voltage circuit. High voltage circuit, that is AC circuit. Okay, and now output I'll actuate the motor is off. Okay, so what are the things what are written here? The sensor part, the low voltage processing part, we have seen not S equal to 1, so V output then will get 1, so this has to be made S1 should be off or on based on the switching. Okay, then this will be controlling high voltage AC circuit, 230 volt controlling the motor. Ultimately motor will be controlled, made it on and off. Okay, so whenever you talk of this circuit, whenever we interface with a low voltage circuit to high voltage circuit, we usually use a concept called relay. What's a relay? Okay, a relay is simple on off, you can say relay is a switching mechanism. Okay, okay, so whenever we have a connection between low voltage DC voltage to AC voltage, also you can use a relay, because relays can be interface. Relay means, I'll just show you what is relay. So if you want to define relay, you can say relay is something which relays are switches that open and close circuits electromechanically or electrically. You can see transistor we already discussed is also electronic relay. Okay, cable is on off switch based on some conditions. It's on off two points. So it's an electronic relay, you can say transistor, but electromechanical relay is also there. So electromechanical relays works on the principle of electromagnetic and electromechanical motor, even thermal also. So usually relays are represented like this. We have seen in some circuit something like this. So the basic principle of relay is your two terminals. For example, I can this is called T1 and T2. Okay, and based on this terminal, okay, this is a magnetic winding, so inductance core, and it produces a magnetic field. Okay, so I just represent like this magnetic core. Now this is one part of the circuit. For the other part of the circuit, now based on this, I have another 2 points. Okay, this I can name something like T1, T2, O1, O2, output points O1, O2. Okay, now I'll add one control mechanism here. Now I have a control mechanism. I'll just add like this, a small switch or kind of, we can say this kind of relay switching. Relay is simple, a metal plate, whatever. So I just want to explain the concept. What is the concept here? Whenever there's a current passing in the passing through the primary circuit T1, T2, for example, you have some current I or voltage in the primary circuit. What happens? There is a magnetic field generated in the in the core of the inductive or the coil. So what happens? This magnetic field attracts this switch which is kept in the right side. Okay, this attracts the switch and this makes it come closer. Attracts. Magnetic means attraction or repulsion. So this makes it attract towards the 2 points of O1 and O2. Now it becomes on. So whenever there's a signal or a voltage or a current passing, whenever there's a signal passing in the T1, T2, what makes the relay get energizes? Relay energizes and makes on. So the O1 is right now shorted to O1 is right now shorted to O2. Getting? So this kind of relay I can tell as electromechanical. Why electromechanical? Because it is using electrical property, magnetic property, and based on the magnetic attraction, I'm attracting a coil towards it and I'm connecting O1 and O2. Okay, so it's called electromechanical. One more point you can notice, this relay is normally open, NO. You can say this is a NO type relay. Why? Normally it was open. Normally there was no connection between this and this point. So normally it was off or normally it was open. Okay, okay, ready? So this is called normally off relay, normally open or normally open. And another type of relay is also the which is normally closed or normally closed relay. This or so how can I write draw that thing? That relay will be like this. Whenever it will be normally on. This will be already normally connected to each other, normally on. So this is my whenever I'm energizing my signal in the primary circuit, what happens? Because of the magnetic repulsion, it is going to disconnect the connection between O1 and O2. So that kind of relay is called normally closed relay. Normally it is connected, but when there is a field or energy energizing magnetic field there, it becomes off. That's it. So whatever discussing here, we are discussing using a small DC signal in the input primary. We can connect a high voltage components in the this relay. So what I'm doing, for example, if I do like this, what I'm doing here, I'm connecting a motor with a AC signal, with a high voltage AC signal here, high voltage AC signal, AC. Okay, and based on the relay on and off, my motor is going to work or it may be put off. Okay, so what happens now? Based on my signal in T1, T2, I can make the motor on and off. Okay, now I have two options. Should I use normally on relay, normally off relay? This is similarly the case of a PNP or NPN transistor. I think we already discussed, right? CMOS, NMOS transistor, PMOS transistor. One is one is on, one is connect. There is a connection between source or connection with the other two terminals when the control terminal is having high voltage, that is NMOS. If control terminal is low voltage, if still the terminal is connected, that is called PMOS transistor. Likewise, we have NPN and PNP working as a switch. Okay, specifically if you remember as a switch. So likewise, we have a relay also, normally open, normally closed, and this is about the normal thing. Another classification of relay is two one relay. There are two terminals. There are multiple terminals can be possible in a relay. For example, this is I'm showing only two terminals. Two to one relay. Say sometimes relay might have also multiple points. For example, there can be one more terminal here. Relay can be like this. There can be three terminals also. So here I'm showing you one more terminal. So what is the idea? Okay, here the relay is like this. Here relay is like this. Initially it may be like this. When energized, what happens? When it is energized, it may be connected to a second terminal. So there are two terminals. This is input. I can call this is input terminal, and there are two terminals. Output one, output two. So this you can see the difference between the previous and this. Previously it was just disconnected relay. Now this relay is connected to O1 always, and based on my relay energization of the inputs, relay energy on the input signal, my relay will be connected. O1 will be connected to, sorry, this is O4. You can see this will be connected to O1 will be connected to O4 or O1 will be connected to O2. Okay, this is one option. Another option is we can have multiple or more terminals can also be possible. For example, I can have one relay like this. For example, you can have something like this also. Have one more connection here. So whatever you want, that is already available in the market, and you can get that kind of relay. So here, how it changes? Here, the relay coil may be sometimes like this. Okay. So how it works? When the current is passing in one direction, it is going to be attracted, and this O1 is connected to this is going to connect in these two terminals. When the current is passing in the opposite direction, it's going to repel and is going to connect other two terminals. Okay, this is O1, this is O2, this is O3, this is O4. Okay, when I have a positive current flowing from T1 to T2, when I have current flowing from T1 to T2, the O1 and O2 will be short circuited, or that will be connected through the relay coil. Okay, when the conductor will be attracted. If the current is from T2 to T1, maybe the coil is repelled, and O3 and O4 will be connected likewise. So we have different levels of connections also relay can be classified again. So but here what I'm going to use here is simple relay. For example, I'm using some relay here. This is a coil. Usually relay is shown like this. Okay, so this actually I think is shown like this. Okay, and I have two terminals. I call it two terminals, something like this. Okay, so one terminal I'll give it to my motor. Okay, another terminal I give to my input AC supply. Okay, and again I need. Okay, so this is fine. Okay, now whenever my relay is energized, what I'll get a motor on. I'll get the motor on. Now to make the relay energized, I have different options. So for example, to make it safe, I need always isolation. Isolation means, so here what the another advantage of relay is just what I call isolation. Here you can say the this is low voltage circuit, this is low voltage circuit, this is high voltage circuit. Relay gives me isolation. You can see now they are isolated together by the magnetic field. You learn transformer, so it's transformer. There's isolation. So this is one of the isolation which the same principle relay is also offering us isolation. So high voltage circuit, I'm not disturbing the low voltage circuit. So low voltage I'm sensing and processing, high voltage I'm actuating. Okay, so very simple. Now we have placed the relay. Now, what else you can see what I'm going to do. I'm using small transistor. I'm using a transistor. Again, I need some kind of isolation. I am using a transistor as a switch here. Okay, place it before the relay, and this this may be 12-volt relay. So I'll give a plus 12 volt here. 12 volt. Okay, you can see different voltages we are interfacing. The relay is operating on 12 volt, so I'm giving it 12 volt. The motor is operating is 230 volt, so I'm let it 230 volt 50 hertz. Yeah, I'm giving it that supply. Okay, and I'm connected relay also. Now this transistor has to be on when the motor has to be on. When the transistor is on, I can say there's a current passing through the relay. When the current passing through the relay, you can say the switch is on. When the switch is on, motor is on. Getting? This is my idea. I'm using a electronic switch, a transistor here. Okay, now the transistor input has to be controlled based on your water level in the tank is full or not. Okay, now when the water level in the tank is full, what should I do? Should I on the motor? No, I should off the motor. If I want to off the motor, or the transfer should be off or on. If I want off the motor, transfer should be off. If I want on the motor, the transfer should be on. Getting? And only relay will be energized, right? Okay, so this signal, how can I get? Now I'll draw my water tank also. This is my tank. Okay, tank. I'm already fixing my battery sources like plus and minus, this plus minus. Okay, and minus I'm grounding. And for example, I'm connecting one metal conductor to the top. Okay, I connect one metal conductor to the top. Now, now you can see now there is some kind of solution here. I have one conductor. So what does this wire get? Now, if what is happening if I directly now we can see the logic. If the water level is full, if the water level is full, this is empty, and water level is becoming full. What happens? What is the output I'm getting in the wire? I'm getting a high value here, right? Water level is full. That means when the water level is full, I'm getting, so you can say this is wire W. W is becoming 1 when the water level is full. Okay, I'm just addressing the logic only. I'm not properly designing all the parts of even resistance. I'm just giving the logic. Right now, first at least logic should be clear, then we can easily design any circuit. Okay, so when the water level is high, now the motor should be off, right? Water should be off. So if I connect directly, uh, if I connect this directly to the transistor base, what happens? No, transfer will be on and the motor will be on. So I need to off the motor. So I need to change the logic. So W is 1. So my W is 1. I should off the motor. That means W is 1. My motor should be off. Motor should be off. So motor off means relay must be off. Relay off means transfer should be off. Get it? So W equal to 1, wire is getting high value, transistor should be off. So reversely, if the wire is getting low voltage, that means tank is not full, the transistor has to be on. Okay, then only the motor is going to run. Okay, okay. So that is the logic. So what I'll do, I need to uh, I need to use a inverting logic here. So what I'll do, I use inverting logic. That is, I use a simple inverter. There are multiple uses of this inverter. It can act as a strengthening voltage strengthening scene also. Okay, so I'm using inverting logic. So now you can see, assume the logic is right. So whenever there is a water level is high in the tank, the inverter input is 1. So input output is 0. Okay, that means the transistor automatically going to off. Transistor is off, relay is off, the motor is off. Now, when there is no water in the tank or the water level in the tank is not full, it's not, I'm not saying there is no water. The water level in the tank is not full. That is my condition. The water level in the tank is not full. What happens? The signal getting here is 0. That means 1 is output. So now the transistor is on. The relay is energized. The switch is on. So motor is started running. Okay, so this is one of the simple logic, and this is what we see in the normal. We can see that a lot of circuits are there, but now we have to see whether protection protect. You need to control the current flowing through the different circuits. So you may keep a lot of resistance here. You may keep some resistance in the base of the transistor also. That are for protection as well as voltage, proper control of the voltage and all those things. Okay, now when you see any circuit from the net or any book, you can see a lot of other parts are also there. What are these parts? These parts are used for making these voltages, 12 volt here and this 9 volt. So these voltages in the circuits in the books and your projects books, they use a IC, voltage regulator IC, and a filter for all these DC voltages. So you may see a lot of ICs are there, yeah, but you see what they are for. They are just for generating a constant DC voltage. Okay, so if you see, ultimately the logic is very simple, but you may see a lot of things. But now in this circuit, you should always, it is always recommendable that when you design something, you should give a manual switch for the motor. This is already there in your home. You already have a manual switch in your motor, which can on and off the motor. Okay, so when the manual switch is on, then the whole sensing and everything is working. Okay, so this is a manual switch. This is very important. Manual switches have to be kept. Okay, and your circuit can also have a switch that I can keep it here. Your electronics part can also have a switch, so that you can wish when to make it on, when to make it off. Sometimes it is desirable to make it off, so I'll have a switch like this also. Okay, so have a manual switch there. This also controller switch. You can see as a automatic water level controller switch, ACS. Whatever. Can give your own name. Okay. So when the ACS is on, now the whole sensing part is activated. Sensing part is on. Okay. No, the motor is on when water level is not high, and water level is high, the motor is off. So we should have proper protection. So this is just I need to give an example, and you can first you have this idea, then you try to simulate using the simulator, then you're satisfied that okay, there's no problems. And so before designing something, you should make sure that you take some guidance that there is no problem because we cannot make everything on our own. And at least in starting, we cannot blindly make something. You have to take some advice also. Okay, so I think this is one of the ways we'll design automatic water level controller, and there are other ways also. In other ways, means usually you'll use some ICs. You will use some ICs. So triple five. There's a timer IC, triple five timer. So what this IC is used? This IC is used for uh, getting some exact timing delays. For example, I should not tell you, but you can there are some people designing bomb, electronic bomb. So how they design? They use this timer. Okay, so this will give you exactly whatever time you need, give you time. So you have to, how the timing is getting, your timing is got by the RC. There's a resistor and capacitor which you provide in the output outside the IC, and based on the RC timing it will give a high pulse after. For example, I'm giving example. Suppose the IC is on, that is on at this point. Now at a particular time, whatever time you can set, you'll get a high pulse from this IC, maybe 5 minute, 10 minute, 30 second, 1 second, 2 second. So that is advantage of this IC. Okay, and you can also clock wave some using this IC, and whatever duration of this pulse width you can decide based on the. So this is negative, this is positive, or high low thing. This T1 T2 you can decide. Okay, so it is used for making clocks. It's a pulses waveform. It is also used for controlling the motors. It is also used for making sounds, different frequencies using loudspeaker. If you give output to loudspeaker connected to triple five, output is connected to loudspeaker, varying the different frequency. You can make different kinds of sound, etc., etc. So this is one of the very useful ICs you may come across. Timer IC, triple five timer. Okay, there are different variants coming. Double five six is also the two timers combined. Okay, and another thing you may use is op amp IC. It's simple amplifier, operational amplifier, which can be used for different comparators. You can use a comparator that will discuss in the last unit, I think. Module 5 we have a operational amplifier basics and circuits design using operational amplifier. This can be used as amplifier, filter, whatnot, anything. Any operation can be done using this. This is called, we'll discuss in the last module. This is another thing, and these are the one of the main things when you should know. And one of the another things are this thing. We have a lot of ICs. Like some ICs, their name is 7805. Okay, this will be coming like this. Okay, you can get it like in all. You can have different options like 7805 instead of 705, 709, 7812, 78 any number 7812, 708. I think all these numbers are coming. So what is the last two digit? Last two digits give the voltage. It is going to regulate the output. 7809 means it is going to give a constant 9 volt in the output. 7812 means it's going to be 12 volt in the output. Okay. So this is three terminals. This is input. This is output. This is common terminals or ground, something like that. Okay. So within even in the water level circuit, you'll see there is a 7005 IC in the circuit. In this circuit we can 7812 because we are using relay of our relay was, I think you remember that our relay was a 12 volt relay. So this is output of the 7812 is connected to relay and transistor like that. Okay, and we have to input can be varied from 0 to 15 volt also can be possible. DC voltage, now whatever the input voltage 15 voltage gives a 12 volt the output. So that is called regulator. How much? 1 to 7812 regulator. If you're using some 7809, it will give you 9 volt output. Okay. Still, the data sheet. You have to read the data sheet of this thing, and you can see there is a lot of capacitance. They are telling that you need some capacitance also when it is working. So the IC you have to keep capacitance, and whatever point is ground, you have to ground it also. Okay. So these things you have to see the data sheet, how the ICs are working, and how to make 12 volt, 5 volt, 10 volt, 9 volt, all those things. Okay. Then so each of this So what is the input to the 7812? So input to 7812, you can see, you can then again you can see there is a transformer. Then you can see another rectifier design coming here. Sometimes you may see bridge rectifier. Okay, bridge rectifier. You remember bridge rectifier is consisting of 4 diodes. Okay, and now this output is again going to 7805. 7805 if I need 5 volt in the output. Okay, something like this. This kind of circuit you will see outside. Although you don't need to worry about this, are all very fine. This is a regulator which gives you 5 volt output. This may be output voltage may be 10 volt or maybe 7 8 volt. Okay, this is maybe 230 volt. 230 volt. I am giving putting down or um, using a step down transformer making 8 volt, 8 volt or maybe something around 8 volt. So although now bridge rectifier giving 8 volt, but using a 7805 I can get 5 volt in the output. Okay, so these things, lot of circuits you will see in your outside websites, or you may see in the books or electronic for you magazine, electronics today magazine. So there's a lot of things, but if you divide into different blocks, this is for voltage generation, DC voltage generation, and this circuit is for motor current control relay part, and this is for my processing and sensing part. So if you divide like this, you think things will be very simple. Then you will understand this transistor is used for this thing, this transistor is on when this is high, this is low, this etc etc. So you should, my point is, you should start thinking about, you see a circuit, you should think how this is working, what's the problem happening, why I'm not able to understand. Mostly you're not understand because you're not able to understand what this part is doing. So first thing, what are the requirements here? I need to generate a 12 volt or 9 volt or 5 volt, and I need to generate a motor high volt, control the relay here, this much voltage. So what I'm trying to, I need to sense the signal. What signal? The tank is high, I'm getting a high at this part of circuit, and etc etc. Okay, so you have to divide the complicated circuit into different parts. Okay, then you'll be easily able to identify, okay, this part is doing this thing. Then you may think, okay, why this part is doing that? Then you refer the data sheet, you will understand, okay, this is the data sheet is telling that you should keep a keep a capacitor with the 7805. That's always good for better output. Okay, so we'll keep this also. So rest of things are actually a lot of thumb rules. Okay, rule of thumb is there, you should do this, you should do this. So that will you will learn only if you are able to, you're trying to understand the circuit and implement something. Even simulator also we can do a lot of things. We can try all those things. Okay, a lot of projects are done even by beta students. They can done using these simulators these days. Sort of things. So that also has, so in simulation you can go for a bit complicated circuit also. Manually you take a simple circuit and try it first time, and you will feel it okay. So even if you're designing a 5 volt supply, 5 volt supply like a charging device, 5 volt charger, something. It's a good thing starting. In simulation, you can go for something more difficult or challenging. Any comments? Any comments or any clarification required? Anything? You can ask right now. Else you can put your roll number. Okay, you can stop recording as well.